This is the first workshop for winning projects from the Soneium Spark program, and I'll be hosting another workshop for all the participants. So let's get started. Very excited. So basically, Ava Protocol is an intent-centric EigenLayer ABS, empowering private and autonomous super transactions for EVM chains. So what does that mean? Basically, Ava Protocol is revolutionizing smart contract automation through a few key components: account abstraction, EigenLayer ABS, and our proprietary event-driven execution model. Basically, it's a developer-centric solution for all types of Web3 application built by developers and for developers. And with this solution, we're enhancing dapps with scheduled payments, stop loss trading orders, streaming NFT rewards, and more. Web3 users can easily schedule and automate functions across multiple blockchains, including Ethereum, ensuring efficient and reliable execution without compromising security. So right now, we are working with developers, streamlining the DevOps for them, trying to lower their cost and help them launch faster. But in future, we can work with DeFi traders, NFT users to help them streamline their strategy. This is a very high level technical stack for our solution. I'll just quickly go over this. As I said, the account abstraction or smart wallet is the first key component. Basically, the difference between our solution with existing ones like Alchemy and Tenderly is that we can trigger Web3 actions like transactions on Ethereum based on either Web3 signals or Web2 signals. So the current developer tools that the existing solutions are offering are trigger some Web2 webhooks based on Web3 actions, transactions, event on chain. Right? For example, when TVL of this pool surpass a certain amount of number, you get an email notification, you get a Telegram notification. Right? Webhooks, the concept that we're already familiar of in the Web2 world. But our solution is that when something happens, you can trigger a Web3 transaction through your smart wallet because the smart wallet incorporates a dual control model that you owns it. We can control it based on the permission you grant us. So that's why it's the key component. And then EigenLayer ABS, for anyone who is not familiar with EigenLayer, basically EigenLayer is a network. So we are one part of the network. Is a network that use off-chain computation and storage to delegate the calculation from on-chain. And it's backed by Ethereum validators in our case. So our ABS is backed by 32 operators with $2.5 billion backing in ETH. We have built a strong trust from the EigenLayer operator network. So everybody forms this decentralized network and ensure that our transactions are triggered correctly. So as I mentioned that you want to trigger some action based on the Web3 events, and those are not triggered by us. Those are triggered by a decentralized network that the EigenLayer operator brings. And on the left is that we can allow users or allow developers to choose any oracle they want because they are just Ethereum smart contract event on chain, and we can write to multiple blockchains. A very powerful use case is that when something happens on Ethereum, that you can trigger something on Arbitrum, right? And similarly, even on Ethereum, let me give you a more specific use case. When price change on the Uniswap pool on Ethereum, you can trade either on QuickSwap or on Polygon, or you can trade on Uniswap on Arbitrum. So it's this modular design just allow user to be our solution to be very flexible and versatile, so users can make any combination they want in their strategy. Feel free to stop me to ask questions if you get any. So eventually, this is the UI we're building. So right now we have the backend API. Today, the plan is to show the backend, to walk through the backend API. But The UI we're building looks like this. It looks like this, a little small, but on the right is a flow builder. So basically, through a drag drop tool, you can drag like triggers. Let's say, technical article price, subquery queries. Those are triggers to get a signal from on-chain, and then condition. The condition is based on the output of the triggers. When price oracle value is like this, and when subquery give me this feedback, this output, I want to do some condition. For example, when price is over $2,000, you can drag an action here to say, I want to, for example, take my liquidity out of the Uniswap LP pool, or you can say, I want to trade my asset on Uniswap or any other DEX or 1inch on Ethereum. So through this very simple drag and drop tool, we allow you to build a trading strategy within a few clicks. So normally developers would write their code, put their code and the private key on AWS server, set up the AWS server securely, make sure nobody have access to it, and deploy to AWS. Have it running, then use some other tools to get signal, to monitoring the result, monitoring the logs. With our tool, we can do that with 4 clicks. So as long as you have a good idea, even simple idea, for example, when price is above a target, you want to trigger something. As long as you get the idea, you can do that within 30 minutes. All right, that's a brief introduction. Let me know if you have any questions. But I'll start the demo. Yes and no. We plan to support all EVM blockchains, but right now we support Ethereum, Subsobolia testnet, Base, and Soneium Minato testnet. So right now we can only do 4 chains. But the idea is to scale that up. Probably in 6 months' time, we will support Arbitrum, Polygon, all those chains. Today's demo is against Minato. All right, let's take a look at the demo. Quick introduction of the Minato testnet. We have the RPC endpoint here. I'll share the deck afterwards. You can ping me from either Telegram or our Discord to get the information. So we have RPC endpoint here. We have Explorer. Let's take a look at it. This is Mintaro Explorer, which is very nice. If your MetaMask hasn't added a Minato, you can do it here. Click on this button. The network configuration will be added to your MetaMask. And here is for the Connect wallet. Our demo will be talking to this RPC endpoint because we need to check balances, get the transactions, and for the deploy the smart contract, the first 2 are our account abstraction implementation. So we won't be interacting with those because these are already configured. And we'll check out this demo token contract and price oracle a little bit later. So basically the token contract is a test token and anybody can mint it. So this is very nice. This allows us to get tokens from the faucet and test the ERC20 tokens. And this is the fake Chainlink oracle. Basically, we can set the price. So right now, the price is set 8,000. So we'll change that a little later. All right. The first step is to show the authentication. So I'm at EigenLayer AVS examples. Eventually, all the examples will be moved to the SDK. The SDK has all the code. For example, it's quite simple. It's a wrapper around our RPC, right? Like JavaScript wrapper. What I'm going to show is that I'll just run this test for authentication. What it does is that it signs a message. Well, the private key is in my environmental variables. So basically, we load the wallet and we sign from the command line. We sign message. So this is the message used to authentication. As long as you can generate the correct signature, we prove that you own this EOA wallet. Basically, you pass the authentication test, and then we can start to do the following operations. And the first operation we do, we're going to use this command line, very nice command line output built by our developers. So just call this code here. So node example. And you can see the usage of this API is quite simple. To get a wallet, to get a task, get a single task, and then we have a few schedule functions. We'll keep adding more functions here, but I can show you regarding the custom smart contract. I can show you how to do it. All right, these are the operations. So I just show you the authentication. Then we'll do wallet. All right, it returns the address. This is your EOA account. That's in my environmental variables. And then we tell you, okay, this is your smart account address. And announce is 3 and balance is here. So we need to top up. We need to top up this smart wallet so it can act on behalf of you, right? Like it needs to send the transactions. Or we can do a approved call, allow the smart contract wallet to do something on your EOA account. But let's just top it up. We're gonna go to the Inatol Explorer, go to the test token smart contract. We're gonna mint. So basically copy this smart wallet address here and mint 10,000 tokens. So we need to click on this button to make sure it's 10 to the 18 and then write and just sign a smart contract message. It can be signed by your EOA. So basically we're telling this smart contract, hey, give me 10,000 more tokens on this smart wallet address and the transaction has been confirmed. So let's see. All right, we got 10,000 more test tokens. And similarly, the same thing for the price oracle. So we'll do write a little bit later, but right now you can see the price oracle, the price is at 8,000. All right, this is the smart wallet, and then we'll do a tasks. It says task has been created by this EOA account, and these are the task IDs. As you can see, there are some active, some completed. We'll schedule a task for now. To schedule a task with the chaining price when is conditioned to be matched quickly. For simplicity, we don't have any input here. We write all those into the examples. All right, so schedule. This is a task body. It's not a human readable because it's for the machine. But here is the condition. The core thing is that we use this expression that is very powerful for support any kind of description. So right now I'm describing the condition B when the price oracle, its price surpassed 10,000, I want to trigger something. So basically this means, okay, when the price is above a certain threshold, I want to trigger something. Yeah, so we have a condition here, but before we go into that, we'll do a get task because we have the ID here. So get 1015, and this is the completed detail of the task. So it's very easy from the interface level, but it's technically deep beneath it because as you can see, there are so many parameters in this task. I'm not gonna go over these today. These are explained on our documentations. Will be. I think it's not yet because it's very complex. But as I mentioned, the expressions is here. That's the core thing. And we have the expiration, we have the memo, all these detailed information to help users understand what was this task about, right? What was going to happen. And the task type is a contract execution. And what are we going to do is we're going to transfer some test token when the condition meets. All right. So we know that the goal is that when the price is above 8,000, we'll do something. Now let's go ahead and do it. All right. This is a 1015. This is the task that we just created, requiring the price of the price oracle to be over 8,000. So it's still active now. It's still running. We're going to do here, we're going to write to the smart contract. We're going to set its value to 12,000. Remember the condition is 10,000. So we were below the 10,000 and now we're setting it up to more than 10,000. Cannot destruct the gas limit. I think this is the interaction problem. Let's do it. Regular cannot destructure properly gas limit of as it's not. It's a Vim issue. Haven't seen this before. Verify and publish. Let's try something different. How about 800? 800 works. All right, now we're changing the price to 800, which will not trigger the task. So 800, right? It's not triggering this task. We need something bigger. How about 12,000? There you go. It works. All right, transaction has been confirmed. Now the price is 12,000, right? So let's see. Now you can see the task has been triggered. Basically, the network is our backend is monitoring the transaction every block. As soon as this confirmation happens over here, we capture the price from basically the state of this oracle, and then we trigger this Web3 action immediately. And you can see all the detail here. User ops hash is whenever this transaction actually happened. This is the transaction hash. We call it the user ops because that's the implementation of the smart contract, smart wallet. So all the transactions triggered through the smart wallet are called a user ops. That's just the ERC 4337 definition. By the way, we saw some errors before. I think this is the interaction tool problem. But a reminder that you need to get Minato ETH in order to trigger any transactions. And we use Alchemy Minato testnet faucet to get the ETH. Like you can only get it once in 72 hours. So search for Alchemy. I have a link here, but I don't have in the chat. Alchemy Minato testnet faucet to get the ETH. All right, then very simple. We trigger the task, and now I want to delete the task. I want to delete the 1015, right? So I will just do node example, delete. Sorry, not all right, 1015. So value is true. The delete has a very little problem as long as the ID is right. For example, this ID wasn't right, and we need to have a better output message. But basically, the server tells us key not found. So as long as the key is found, we haven't seen any problems deleting that. And then we'll cancel one. We'll cancel this one. We'll cancel 1006. Node example. Cancel. So this cancel is important because sometimes you just don't want the automation anymore, and we'll just cancel that. And you can see the status is over here. Yep. This is pretty much the demo today. As you can see, very simple. But as you go into the code, I'll show you the code a little bit. As soon as you go into the code, you'll see the details. Actually, a lot of, well, this is a setup. We have local development, we have staging, which is basically Sabolia. I mean, this is actually Sabolia because the RPC endpoint here. And Minato, we have Minato here, and then production is Ethereum mainnet. I mean, zooming a little bit. The example is very straightforward. The power lies in the gRPC endpoint that we're using. So gRPC is a very self-explanatory that all the parameters are defined on the server side, and the SDK would just match the definition, like a type definition, with the server side. So it's more streamlined. And we have all the code here and some code behind the scene in here. But eventually we'll move all the code into this SDK. So SDK, the code works, but the demo is in the other repo. That's how it works right now. But the test cases, the best way to check it out is to check out the test cases because the implementation are in the test. For example, it's client E2E test. For this test, we're talking to Sabolia, and we have all the code. You can just copy this code and, for example, do authentication, and do list task. This is basically get a task list, to get smart wallet address, basically call the SDK. All right, that is all for my demo today. Let me know if you have any questions. Good question. Right now we allow only ETH, and the fees on Ethereum is 30 cents, and on the layer twos, for example, Base is just a few cents. Cause yeah, I think it's 2 to 3 cents by the smart wallet. Yeah, whenever the transaction is triggered. Yeah, basically, I mean, the fee is a complex topic. Eventually, we would charge the fees based on the storage and the computation. For example, if your task has lived on the server for about a year, the fee will be higher than living there for a day, right? So we'll charge based on that. But right now, it's just flat, and we keep it reasonably low to match the gas price on each chain. Yeah, by the network. It's a network. The EVS is a part of EigenLayer network. You can think of that. For example, we have there are more than 200 validators on the EigenLayer, and we have 32 of them. So it's a subset of the EigenLayer operators. And the role would be triggering, monitoring the on-chain events, and do the calculation, compare the price or do some calculation, and the triggering. So basically, AVS is the backend. Like whenever you interacting, create a task or triggering task, it happens on the AVS. Yeah, sure. It's a little complex if you dig a little deeper in, but it's a very interesting story. Basically, it's off-chain storage and computation backed by decentralized network. You can think of that as layer two actually, but instead of layer two batching all the transactions and put them back on Ethereum, we actually interact with Ethereum and Soneium chain directly. So that's the difference. That's why it's faster. And your asset would never leave your primary chain like Ethereum or Minato. So that's very powerful. It's this new thing this year that we believe has a huge potential to solve the fragmentation of liquidity problem. That's why we seize the opportunity. We launch our EVS this May. Yeah, for more questions, I encourage you to either you can chat with me. Let me disable this. You can either scan the QR code and join our Discord, ask question there, or I'm gonna leave my personal Telegram here because you guys are from the winning team, right? How many winners we had? I remember 15, 17, 14. Okay, 40. Nice. 31. Okay, cool. Yeah, because you guys are the winners. I'll just leave my personal Telegram there. Feel free to DM me if you encounter any issues. Try out the SDK, and I'll create a group with our devs to answer all the questions. Yeah, I'm the founder, Chris Lee, founder of Ava Protocol, and this UI will launch in about a month. So when the UI launches, you don't. I mean, UI is pretty much can do everything we do today. It's just more interactive. Like if you don't want to go to the command line, gate clone, get all the code, you can go to the UI, set up the box. This page is a little weird, but set up the box over there and set up the condition, and you can see all your smart wallet on the interface. All right, that's all for today's workshop. It's a little short, more compact, but I hope you enjoy the knowledge and hope you give it a try and give us feedback. It's open. All the repository are open. Feel free to just leave a comment in the issue tab or contribute to the code directly. But reach out to us if you get any questions or any ideas to contribute. By the way, the one last thing is that we reimburse the fee, all the transaction fee for the winners of this program for the next 3 months. If you give it a try in the next 3 months, basically there's no cost to you. Somebody just joined. All right, that's all for today's video. We'll put up the recordings on YouTube channel, and we'll give the link to Soneium team, so we can check out this demo later. Thanks for coming, everybody. Cool. Bye.